Welcome students to your favorite channel Pradeep Sir Classes has PSC, and that particular channel runs through the different concepts, and so I want to tell you that be patient till end. And this is the Numerical King series AC Verma solutions, and I suggest you to follow playlist for the particular order of the numericals. And this is Gauss'S law, chapter number 30, question number 21, 22, 23, 24, and this is the final day. So all the numericals of Gauss's theorem from 1 to 24 are completed, and you go to the playlist and see all the concepts related. And for that particular channel you can get all the concepts related with that particular numericals. Not only I solve the numericals, but I relates all the that is particularly the point of view that related with the numericals. So don't go for further details, and just start with 21. And I say you that take a habit of write down the numericals first, and then try, and then pause the video, and then again see the answer. Okay, so let's 21. So what is students, what is about 20, question number 21. So question number 21, two large conducting plates are placed parallel to each other, two large conducting plate. Okay, so question number 21, two large conducting plate, two large two large conducting plates are placed parallel to each other with a separation of 2.00. So the separation is given, that is 2 centimeter. Separation between the plate is 2 centimeter. Okay, and between them an electron starting from rest near one of the plate. So there is an electron at a particular plate, and electron starting from rest near one of the plate and reaches the other plate in 2 microseconds. Okay, find the surface density of charge on the inner surface. Okay, so students, there is a charge at that particular plate, and somehow it is go from that particular plate to that one somehow. So why that electron go from this plate to that one? Question. This is the questions. And so you say that somehow a force is related with this electron. Somehow a force is acted upon that electron. And if you are in your room and your mom say that beta, you have to go from that one to that one, so then you go. So somehow there is a force related with it, that is F equal to Q into E. Okay, so there is an here it is electron, so this is that one, this is the amount of force. Since these electrics, so somehow there is an electric field from one plate to another, that is a charge is related with it. Charge is related. So suppose this plate contains plus sigma, and so that one is minus sigma, because somehow electric field act along this direction. So we can know that the electron moves opposite to the electric field. Electron moves opposite to the electric field. Okay, so electron, this is the force, and we know that force equal to mass into acceleration. So here acceleration equal to E by m. So acceleration is E by m, but the charge is at rest. So U equal to 0. U equal to 0, and it takes a time of 2 microsecond. 2 micro, that is 2 into 10 to the power minus 6 second to reach from that plane to that plate. T. So the distance is S equal to UT plus half AT square. We know that. So here S is 2 centimeter, that is 2 by 100, and this is equal to the initial velocity of the electron is 0, so this is 0 and half, and the acceleration is EE by m into T square. So what is about the electric field? Is the electric field is uniform between the plates? Yes. So the force is constant, and then we can say that force equal to ma. When we can write that F equal to ma? When the force is constant. Okay. So there is a constant force. There is an electric field that is also uniform within the plates, and electric field within the plate is, we know that E equal to sigma by epsilon naught. So you have to find out sigma. So here you have to put sigma by epsilon naught, then calculate sigma. Okay, so we can erase this one and substitute. So 2 by 100. So 2 2s are 4. If we take a cross multiplication, then T square equal to 2 2s are 4 into m. So 4 into m means 9.1 into 10 to the power minus 31. This is the mass of the electron. This is the 2 into mass of the electron into 2 divided by 100 into E into E. E into E. And in place of E, we can write sigma by epsilon naught. So this is epsilon naught. And if we interchange sigma in place of T square, then 4 into 9.1 into 10 to the power minus 31, 10 to the power minus 31, then epsilon naught, that is 8.85 into 10 to the power minus 12 by 100 into electronic charge 1.6 10 to the power minus 19 into T square. T square means 2 into 10 to the power minus 6 and then whole square, 2 microsecond. So this is the answer, and the answer is, and the unit will be coulomb by meter square. Charge by area, that is sigma, surface charge density. Okay, so that you can get the answer. So the 21 is here it is given 0.505 into 10 to the power minus 12. So this is the answer, coulomb by meter square. Okay students, so I think it is a simple one. Again I repeat again, there is a plate of separation and it is given, separation of given, and you have to calculate what is the surface of density of charge within that particular plate, and the electron somehow it is moved from this one to this one with a very micro nanoseconds, 2 microseconds. So it is so simple. You have to apply just S equal to ut plus half AT square, where acceleration equal to force by mass. So force, where is the force? Because there is an electric field. So what is about electric field? So there is the surface charge density sigma by epsilon naught equal to E. So you have to calculate sigma. Okay. So we must go for the next one, that is 22. Okay. So question number 22. Students, write down the question again and try, and always be patient of the numerical. If you've done 1, 2 or 3, or it may be all the numericals in a day, there is nothing but you have to clear your concepts. So you have tried one by one and clear your concepts, at least 1-2 numericals per day, then I think it will be better for your concepts. So the question number 22. So question 22. And 2 large conducting plates are placed. So So you have to choose the students that particular numerical that can clear your point of view a larger amount. Okay, so each and something, it may be a numerical so that it can clear your concepts, suppose one or two, but there are some numericals, it may be the classical text series, Erode solutions, or the concepts of physics, it can clear your point of view a large amount. Okay, so you have to follow that particular series, or you can do for easy numerical book, SLR or comprehensive physics, a different numericals book. There is errorless physics, it may be used in quota. So there are different numerical book you can follow by DC Pandey. And so question number 22, and it is two large conducting plates are placed parallel to each other, and they carry equal opposite charges with surface charge density sigma. Okay, so this is a two large conducting plate. Okay, plate two large conducting plate yes, are parallel to each other, and they carry equal and opposite charge. So this is plus sigma and this is minus sigma. This is plus and this is minus. And find the electric field at the left of the plate. So this is the left side and this is the right side, and this is the center, and in between the plates and the right of the plates. So okay. So students, it is so simple. Think about the concept for a conductor. Suppose this is a conductor, and if you given some charge on it, then the charge resides on the outer surface. Charge resides on the outer surface. So since there is no charge inside the surface, if you take a Gaussian surface and if you apply Gauss's theorem for that particular one, and you have to calculate electric field at that point, then E dot ds close integration, and this is equal to Q by epsilon naught. Okay, so Q means Q inside. So what is about the inside charge on that particular charge conductor? So you can say that the electric field, the charge content at that particular point is 0, since the charge resides on the outer surface. So the charge is 0, so 0 by something means 0, so electric field is also 0. So at that point electric field is 0, since there is no charge within the surface of the conductor. So what is about a plate? So we can say that all the charges resides on the outer surface and there is no charge inside, or we can simply say that electric field line cannot penetrate that particular one, cannot penetrate the particular surface. If this is a conductor, suppose if this is a conductor, then charge can originate from a particular one. So charge can originate from this one electric field, and that ends at that point. It cannot penetrate that one. So there is nothing amount of electric field, or there is no charge inside. So the electric field at that point is 0, because electric field originate from this one and end at this one. So here it is, electric field is also 0. So for left side and right side, the electric field is 0. But what is about on the inside surface? If you take a surface, this is the surface one, then electric field are crossing that particular one. Suppose students think about that this is a book and all the charges are that particular one. And if we take a Gaussian surface here, then all the field lines penetrate that surface like that. Okay. So this is a surface, this is a surface. It is a three-dimensional configuration, so it is a you think like that, so it is more easier for you. So this is a surface, and this surface is, you can take as, it is a large conducting plate, so you can say that this is S or ds. You can consider, suppose this is dA, suppose this is a dA. Why is a vector? Because it is directed along this direction, so this is a dA vector, and the electric field also along this direction, so theta equal to 0 degree, and you can apply E dot ds or dA for that particular surface, E dot dA, and this is E dot simply you can write EDA. Why EDA? Vector is not given here because theta equal to 0. So EDA equal to net charge. Net charge means Q inside by epsilon naught. So Q inside within that particular surface, charge equal to surface area into sigma. Surface area into sigma by epsilon naught. Since sigma is the charge density, then we can say that sigma equal to total area by total charge by total area. Total charge by total area. Total area. Or you can think as sigma equal to dq by dA. And so charge enclosed at that particular one is Q inside. So this is dA into sigma and EDA. So dA and dA cancel, and this is sigma by epsilon naught. So the electric field at that point is sigma by epsilon naught. It is so simple. So just you have to think a small area along that one. If we take a small area along that one and we consider a cylinder, then from this area electric field lines originate and penetrate that surface like that. So there is a flux linked with that surface. And what is the amount of flux linked? There is EDA equal to Q inside by epsilon naught. But what is the amount of charge content within this surface? So this is a small amount of charge. There is dA into sigma. So dA cancel, and electric field equal to this by this one. So it is the definition of flux. And closed surface, what is about closed surface? Yes, thus this cylinder is a closed one. So if I take a closed surface integration, then you can get EA. That is total area of the plate. Then you can also show that the total charge by epsilon naught. And so you can get A into sigma by epsilon naught. And in this way you can get E equal to sigma by epsilon. Okay? So this is the flux, net flux. Since there is no flux and there is along this direction there is no flux linked. So this is the net flux. So this amount is the net flux. So you can write this the net flux equal to Q by epsilon naught, or you can take a closed integration of E dot ds equal to Q inside by epsilon naught. So closed integration of E dot d equal to Q inside by epsilon naught. Okay. So think about the Gaussian surface, Gauss's law, and you can go for the previous lectures and you can grab that concepts. Okay. So for the next one, we can go for question number 23. 23, it is also a conceptual. So students have realized that particular channel is a more conceptual channel, so you have to grab all the concepts. But before I suggest you, you must read that particular book. Okay. So 23, a two conducting plate is given. So this is a plate, and this plate is X, and another plate is given just side by side. Okay, and Q amount of charge is given to X. So two conducting plates X and Y, and each having a surface area A. Okay, each having a surface area A. So the surface area of this plate is A. Okay, and on one side, surface area, each having surface area A on one side. So if we take a three-dimensional configuration, then we can write as like that. This is a plate, and this is also a plate. This is also a plate. So there are two plates, this one and this one. Okay, and two plates, and the plate X is given a charge capital Q, whereas the other is neutral, and find the surface charge density at the inner surface of the plate. So you have to calculate sigma equal to question mark. So inner surface charge density of the plate. Okay, and the electric field at a point in between the plate. So question number A is the surface charge density at the inner surface of the plate, and the second one is the electric field at a point to the left of the plate, to the left side of the plate. Okay, and the electric field at a point in between the plate, and the electric field at a point to the right of the plate. Okay, so you have to calculate electric field on right, left, and in between the plate. So first of all, students, for question number A, you have to calculate sigma inside. What is the charge density? Students, what is about a conductor? So it is a conducting plate, and the surface area for one surface is A, but there is a charge, Q charge is given. So there is a charge amount Q. So this charge can distribute it over the surface. Okay, so we can think that Q by 2 charge, Q by 2 is here, and Q by 2 is another side. Okay, Q by 2 is another side. Q is divided into 2. So if this is a plate, then Q by 2 and Q by 2, and the total amount is Q. Okay, it is so simple. So Q, so the charge density is Q by total charge by total area. So area is A. One surface is A. For each surface, the area is A. So Q equal to, this is question number A. It is simple or not? Okay. So if your concepts is clear, then it will be, I think, it's too easy. And then students, you have to calculate towards the left of the plate, and the plate X is given a charge, the surface charge density at the inner surface of the plate X. Okay, the electric field at a point to the left of the plate. So students, there is an electric field. You think that electric field generate at that point and goes along this direction. So students, since this is Q by 2, so we can prove that electric field inside a conductor is 0. So electric field cannot penetrate that particular one along this direction. So it is not possible. So electric field just terminate at this point. So there are something a minus Q by 2 charge here, because we know that from plus Q1 electric field originate, and from minus Q1 electric field terminate. So electric field originate from this plate, that is the inner side of the this plate, and terminate at that point. So there is a negative charge must be of that amount minus Q by 2 at that point. But this plate is neutral, so it must have a plus Q by 2 at that surface. So the total amount of charge is 0. This is Q, so Q by 2, this is Q, this is a charge plate, positive charge plate, but since this is uncharged neutral plate, so minus Q by 2, and this is plus Q by 2. So the electric field along this direction will be how much? So this is electric field equal to sigma by epsilon naught. So what is about sigma? Sigma, this is Q by 2a, so Q by 2a epsilon. So this is the electric field. Okay, so the electric field at a point to the left of the plate. To the left of the plate is this one. To the right of the plate To the right of the right of the plate, it is this one. To the left of this is the charge, amount of charge. So it is Q by 2A epsilon naught. So this is also 2A Q by epsilon naught. So this is the answer. Be the electric field at a point to the left of the plate. The electric field at a point between the plate. Between the plate, what is about between the plate? It is this one. And along this direction, if we calculate right of the plate, then this is also Q by 2. So this is for that particular one, it is also sigma by 2A epsilon naught, electric field. So what is the charge? Since this is Q by 2, so the electric field along this direction is this one. Here it is also Q by 2, so this is E1, and here it is also Q by 2, so this also Q by 2A epsilon naught. Okay, so for right in between the plate or towards all sides, the electric field is same. So this is the question number 23, and I think students, you realize that one with a very clear and neat and clear concepts. And if this is not so, then you can comment me and I can clear within the comment box. Otherwise, I take another video to explain that one with some tricky ideas. Okay, so next so students, for the next one, and this is the final one, so question number 24. So question number 24, and this is the last one. So you think that this is much and more harder. So harder is the concept. It is a relative concept. It is, if your concept is clear, then it is more easy. If your concept is not clear, then it is more and more and more hard. So Q plus Q, and this is minus Q, minus 2Q, sorry. And three identical. Identical means, what is about identical? Identical, students, means the two surfaces, all the plates are same. All the plates are same. So three identical metallic plates with large surface areas are kept parallel to each other as shown in the figure. And the leftmost, right, this is left, is given a charge capital Q, and the rightmost is minus 2Q, and the middle one remain neutral. Find the charge appearing on the outer surface of the rightmost plate. Okay. Okay, so this is Q. Since this is a plate, student, so you can easily think that this surface contain Q by 2 and this surface contain Q by 2. Since a plate is a conductor, then charge always resides on the outer surface and uniformly distributed. So Q, when uniformly distributed over the surface, then you can say that this is Q by 2 and this is also Q by 2. Okay. So electric field originate along this direction, but electric field originate along this direction, and there must be a charge at that point. Why? Because electric field can't propagate along this direction. So that for particular electric field, it is finished at that point, that is terminate at a particular point. So there must be a charge of minus Q by 2. Students, if this is a conductor, then electric field originate cannot pass through it. Okay, so since the inside the conductor there is no charge, so charge always remain on the outer surface. So students, think step by step. Step 1, this is step 1. So what is about step 1? Since this is Q, then Q by 2, Q by 3. Why? Because charge always resides on the outer surface of the plate and with uniformity. Okay, so here it is Q by 2, then it must be Q by 2 on the other side. Okay, since the surface area is same. So step 1. Then since this is a plus Q charge, then it creates an electric field, and this field can go through this direction and can terminate at this, because the electric field cannot pass through a conductor. So what is about conductor? There is minus Q by 2, charge is here, but this is a neutral plate. This is the neutral. This is neutral. So what is our neutral plate? There is no charge. Q equal to 0. So minus Q. Then this surface contains plus Q by 2. Plus Q by 2. So this is minus Q by 2. This surface. So this surface plus Q by 2. And since this is plus Q by 2, then it can originate the electric field. And since this is create an electric field, and the electric field cannot pass through it, so somehow there is a charge of minus Q by 2 here. But the total charge is minus 2Q. So this is, since this is minus Q by 2, so here it is a Q by 2. Here it is. So you can divide it this one as minus Q, and this is minus Q. So minus Q minus 2Q, and it must be plus Q by 2 here, plus Q by 2 here. Since this is a charge minus 2Q, so the charge is divided into the two surfaces, that is minus Q and minus Q, and the last one is minus Q plus Q by 2, that is minus Q by 2. So the answer is minus Q by 2. The answer minus Q by 2. Again I explain, students. Again I explain all the concepts. So there are 3 plates, and this is Q and this is minus 2Q. This is minus 2Q. So Q, since it is Q, so there are charge at that particular one is Q by 2, and it is originate from that one. So I terminates along this with a minus Q by 2, and since this is a neutral plate, so minus Q means plus Q by 2, that is equal to Q equal to 0, since this is neutral. Since this is plus Q, so you must have here a terminate Q by 2. This is Q by 2, and since minus Q by 2 is here, so minus Q by 2 is at that surfaces, so you have to give a plus Q by 2 at the opposite phases, opposite surfaces. And since this is minus 2Q, so minus Q and minus Q are distributed, uniformly distributed over the surface. So for that surfaces, outermost surfaces, it is minus Q plus Q by 2, that is minus Q by 2. Okay, so this is the final answer. So what is about the charge appearing on the outermost shell, the outermost surface? This is minus Q by 2. Okay, so students, I think your concepts is clear from 21 to 24, and all the concepts you can show, that is from 1 to 24, all the concepts are given, and you can go through the playlist and clear your concepts. Okay, so thank you, and stay with me, and last of all I want to say, continue your study. Okay, thank you.